Hi everyone, my name is Devansh and I'm going to teach you how to make a box plot. But before we jump onto how to make a box plot, let me tell you what box plot is and why do we use it. Box plot is used to analyze variation in the central tendency of the data. It helps us to understand the skewness in the data distribution. We can understand this just by checking if the box has median in the middle or how lengthy is the whiskers of these boxes are. Now, before we get into the box plot, we need to understand what is median. Let me insert a text box. We need to understand what is mean, which is nothing but average. We need to understand what is median. We need to understand what's quartile 25, quartile 25th, quartile 1 or quartile 3, and min and max. Few things which is very simple. I have, let's assume this is my number on which we are going to work. I've arranged it from increasing to decreasing order so that it's easy for us. So the max number here is 98. The minimum number here is 56. Let me put it on the top. Okay. And quartile 3. And quartile 1 here is 59. This number. Quartile 3 is 73. Median here is, if we arrange it from increase to decrease or decrease to increase, the middle number is 65. If there were two numbers, we would have taken an average of that. Averages, we add or divide by the number, which is 7. That comes somewhere around 50, 50, 50, 50, 350, somewhere around 6. Never mind, we don't require that right now. Let me remove it. What we require is this minimum quartile, median, quartile 3, and max. Now, to help you understand the box plot, let's insert a line. Let's assume this is okay. Now, let me draw. So on the range is, I'll come to range. So on this, if you're going to draw, one line is here. Let's assume, pick up black pen. So 50 and 60, 70, 80, 90. You might want to forward this while checking this video. Kind of slow in this. Okay, 100. Now let's put this number on the scale. 56 will come somewhere here. Let me use another pen. 56 will come somewhere here. There will be 259. Here, just overlapping each other. And then there is, oh, I'm sorry. 59 will come here. Okay, two numbers. Then there is 65. It comes somewhere here. There's another 65 that also comes somewhere here. There is 73 that comes here on the scale. And then there is 98, which comes at the end. Now this is our first number. This is our last number. The distance or the difference between the highest and the lowest, 98 minus 56, that is our range. Okay. So if I connect this to this to this, and this number to this number, and put all of it inside a box. This box will represent my 50%. This is 25. This is 25% of my data. And here I have 50% of my data. Okay. Now another way of the right way of making it is, this shows you the distribution. The right way is, let me pick another pen. Minimum is 56. I mark it here on the scale. Then quartile 1 is 59. Mark it here on the scale. Median 65. Mark it here on the scale. This median, if you see, this is in the middle of the box. It says that the distribution is perfect. But if you look at the whiskers, it means there is variation, there is skewness. Right? But let's move forward. Quartile 3 is 73. Somewhere here, a bigger line. And then max is 98, which is here. Now, even if I connect my second highest to my highest, my lowest with my second lowest, and then make a box, it will be exactly a similar kind of box. Okay. So this is called box plot. Now, how do we make it on a chart? So I'm going to take you to another sheet. Let me stop share and share my another screen with Excel. Give me a moment. So I'm on my Excel sheet right now, and here in the chart, let me change this to okay. So let us assume that we are working on data, sales data, and we want to showcase how the data is distributed, or how the sales is distributed. Sales data is distributed over the entire year. Let's say some year. So we have data divided by 3 regions: AMS, APG, and EMEA, and worldwide. And here we have the box plot on the basis of this data. For this data. Okay. So let me copy this and make it same. Not it. So this is for worldwide, it's for AMS, it's for APG, and this is for EMEA. AMS has the highest variation. EMEA has also does have variation. Okay. Now this is just a dummy data. So don't think that AMS and APG, EMEA, if I sum, it should be equal to worldwide. It is not, just dummy data, but just for the sake of instance, let me sum it up and show you how the box plot will change. Let me drag this down. Now, if you see, if I change it, if I change the data and make it a sum of AMS, APG, and EMEA, my distribution will look like this. AMS here, APG is here, EMEA is here, and some of it is right here. And this is how the data is distributed. It definitely has variation, which is largely driven by AMS. Now let me move back. And let me tell you how to actually make it. Let me make it small. Let me place it right. It's too far. Let me place it here. And let me remove this calculation. Okay. Now, to make the box plot, as we checked in our first session, we need certain data. because box plot defines what is quartile 1, 2. 2 is nothing but the median. Quartile 3, the range is the quartile range, the inner quartile range. Inner quartile range is nothing but quartile 3 minus quartile 1. So that will be the inner quartile range. So how do we calculate minimum? Equals min in which data range? For worldwide, right? So this data range, that's my min. And max is in this range. This is my max, 2650. Now quartile 1, which represents 25% of the data. Like 25% of the data is below this quartile 1 range, quartile 1 number. Now that number is equals quartile. What is my array? My data array is this. I want quartile 1, right? So 1, 965. Okay. Similarly, I can copy and paste it here, but I make it to 3, quartile 3, 2240. What is my median? Median is nothing but here. Now let me do one thing. Let me copy this number and paste it here just for sake of demo. Okay, it's just the values, and I sort it on the basis of smallest to largest. Okay, let me highlight. The 630 is my minimum, 2650 is my maximum. My median is, how many numbers are there? 12 numbers are there. So my median is the addition of this and this divided by 2, and quartile 1 and quartile 3. Now we don't need this. Let me do control duplicate. All right, so this is our file. Let me save it. Okay, now as we have data right here, I can populate it for the rest of my regions. Okay, what is saying that there is an error? Update formula to include what? Let me, oh God, let me drag it to this. Cool. Okay, why is that? Let me check the numbers once. Push the quartile number. Cool, number is correct. Now we need to make the chart, the box plot chart. For that, I have arranged some data over here. Let me do it for you. Equals, so that I require my minimum, and then I need the difference between my quartile 1 and the minimum. Then I need the difference between my median. Okay, I just did that, right? No. Then I need the difference between my median and quartile 1. Then I need from quartile 3 to median. And then I need from max to quartile 3. You got what I'm doing, right? First I took the minimum. Then I took the difference from quartile 1 to minimum. Then I took the difference from median to quartile 1. Then from quartile 3 to median. And then from max to quartile 3. Okay. Now let me copy this and paste this data here. But didn't it work? Now this is same number which I've copy pasted formula. Now I need to make the box plot. So don't take that series 5. I'll tell you when to take. Select this. I need to make a chart on this. Go to insert. Take this text chart, not 100%. Take this text chart. Okay. Now arrange it right here. If you hover on it, it will show you 353. 353 is this number. Then 903. 903 is this number for worldwide. We are checking the worldwide. Worldwide EMS, APJ, EMEA. I'm giving a demo for worldwide. Okay. 903. And then 335. This worldwide series 2. And then 353. This number. Now click on it. Now if you click on this, all 4 will be selected. Right click, go to format data series, go to this icon for format, click on no fill. Okay. And I don't need any borderline. We did not anyways have to borderline, but let me click on no line. Okay. Now I click on the series 2 and do the same thing, no fill and no border. And then I close it, but I let this be selected. And then I click on this plus icon. Why it's not working? Click on this plus icon. It says error bar. Click on this error bar. I go to more option. I arrange my chart right here, or I think I need to do like this. I need some space. Maybe I can reduce the size of the chart. Good. Okay. What I was doing. Oh yeah, let me cross it and do a Control Z. Let me reduce the size right now before I proceed. Okay. And then let me highlight it again. And I need to add the error bar. I click on it. I go to more options. And here I click on minus because I'm for the downward series. I go to minus. And then I fix my percentage to 100%. Okay. And then click on this. Click on this and click on this plus icon. Go to error bar one more time. Go to more options. And last time we had clicked on minus because we were down. And now we are up in the series. So we click on plus. And I come down over here. I click on customs. And I click on specify value. When I click on specify value, I need to specify the values for series 5 and I drag it and I click on OK. Now this is your whiskers box plot. Let me help you analyze one of that. So $630. This starts at 630. In our data, when we had checked, our minimum was 630. It's right here, 630. So this is 630. If I make it format axis, make it 100 just for the sake of understanding. So you see this is somewhere around 630 and highest is max 2650 halfway up here, right? Our median is what, 1868. So this line, this distribution, this demarcation shows us the median, which is 1868, correct? This is how we are going to read the box plot. We don't require this. So let me remove that. We don't actually need this. So go back to format axis, just click on auto reset. Done. So this is our box plot. You can name it here. Sales distribution 0.7. All right, guys. Thank you very much. This is Devansh signing off. Bye-bye.